These gas emissions during volcanic eruptions can also have long-term health effects as well. So one of the things that we see is people who already have chronic respiratory diseases, for example, they may have asthma or they may have emphysema, so they already have a challenge of breathing to begin with, and different things tend to trigger and make these episodes worsen, and they call these exacerbations. And we see that when we have these volcanic eruptions and dust and gases and ash in the air and so on, and it causes the worsening of emphysema, worsening of asthma. We also see a thing called silicosis, and what that is actually, it's where silica that's in the air from these volcanic eruptions actually goes down deep in the lungs, and this crystalline silica, these crystals, once they get down in the lung, they trigger a reaction because the lung knows that they shouldn't be there. So the lung has an immune response and tries to fight with them, and it kind of gets inflamed, and that inflammation causes, obviously congestion. It also causes some scarring as well, and this long-term damage that can last forever as a result of this silicosis that affects some people when they breathe these volcanic eruptions in. We also mentioned as well, I want to take a little bit deeper dive with earthquakes and tsunamis that are associated with volcanic eruptions. And I want to point out, for example, in Mount Etna in 1985, there was some tremors and relatively small volcanic eruption, but there was actually a hotel that was relatively nearby to the volcano, and one death occurred at that particular hotel. So example of, you can have relatively minor eruptions that still cause deaths. And I mentioned earlier before that volcanic eruption in Indonesia in 1883, and that bears some closer investigation, because that particular volcano, that eruption was so huge that it was felt around the world. And I want to talk a little bit more about that particular eruption, because those kinds of things can still occur in other areas of the world, including Indonesia as well. So here was this island called Krakatoa, and many of you may have already heard a little bit about this story, but 33,000 people drowned as a result of a volcanic eruption. How'd that happen? Well, the volcano erupted. It destroyed nearly all of the island, as I mentioned, and then it sent out a tsunami that killed 33,000 people because of the tsunami itself in nearby islands of Java and Sumatra, which are larger islands in Indonesia. They were much larger islands than actually Krakatoa. So people that lived along this coastline were remarkably affected, but it even reached further than that, as a matter of fact. What ended up happening is Krakatoa put so much dust and so much ash into the atmosphere, and it went so high up that it actually got caught in the atmosphere and went around the world. And for a year afterwards, up to a year afterwards, people in Europe and the United States were visualizing and capturing and describing and documenting these sunsets that were actually very, very colorful because of this. Well, it wasn't only pretty, but it also covered up a certain amount of sunlight that could come into the atmosphere. It blocked it out, and it actually caused what was considered to be a volcanic winter, a volcanic summer, where the summer was colder. Crops failed around in different areas of the world. There was less production in those pieces, and during that entire summer after that volcanic eruption in 1883, it was very, very cold in nearly a lot of the places that should have had a warm and productive summer. So these volcanic eruptions can actually make a difference on a worldwide scale. So between 1900 and 2012, I want to talk a little bit about summarizing these volcanic eruptions to give you an idea of the scale of this natural disaster, because it's not as common as some of the other disasters like floods, which are very common. So worldwide, there were 225 eruptions during this 112-year period, about 428 deaths per event. So that's not a lot when we compare that to something like the tsunami or other types of huge disasters that cause a lot of deaths. In addition, about 23,000 people were affected per event. So these are well-circumscribed local events, not necessarily far-reaching. Some of them, unusually so, like Krakatoa, can reach and affect other people around the world. For the overwhelming majority of these disasters, these volcanic eruptions tend to occur locally, and so that's why we want to prepare locally, especially folks that are living in close proximity. I mentioned that Krakatoa eruption because it actually was 13,000 times larger than the nuclear bomb blast in Hiroshima. And the blast was actually heard all the way from Indonesia to Australia. People recognized and understood later on when they heard the newspaper reports years later and months later that this was actually what they had heard was actually the explosion of Krakatoa. And this temperature actually went into the atmosphere and changed the sunsets for 3 years, so it was a very remarkable world event that most people heard of during that period of time. I want to talk about secondary disasters because, of course, we recognize some of these secondary hazards, but I mentioned before volcanoes can cause earthquakes and they can cause tsunamis. Volcanoes can actually cause floods as well. They can knock down lakes that are high up in the mountains and near the volcanoes themselves, and those lakes can actually flood down as well. There can be landslides associated with volcanic eruptions that carry the land and there's a slope failure, and of course there can also be fires associated with this particular eruptions as well. Now, the cause of death when we're looking at natural disasters related to volcanoes, there's a traumatic injury. So a lot of people ended up getting burned. They end up getting hit by these projectiles and so on. The fires that result from that also cause wildfires. Home fires can occur as well, or people can actually be burned by the pyroclastic flow that I mentioned. There are also toxic exposures. We talked about silicosis. We talked about radiation. We talked about acid rain. All of these toxic exposures are associated with a additional threat from volcanoes, so we have to be concerned about the wide range of traumatic injuries, burns, and toxic exposures. Now, there are other implications when we're talking about health. I told you about the air quality issue, and that can be for actually miles, hundreds of miles afterwards, and so we have to really be concerned about people that are downwind from this particular event that carry changes in the air quality and then, of course, have impact on health. Water quality can be remarkably changed as well. In some societies, in many societies actually, people collect their rainwater off their roofs, and then that gets transferred into storage facilities, whether it's a cistern or barrels and so on. But that water quality, of course, when the roof is covered with tephra and the fallout from that particular dust and ash can then cover the roofs, those roofs have to be cleaned. Those water systems then have to be cleaned out before we can have the next rain. Otherwise, now their cisterns and their storage facilities for water are contaminated. People can also get water, for example, off of surface water and lakes and so on, and those can become contaminated by volcanic eruptions. Food quality also is affected as well, and food security can also be affected in that large swaths of land can actually be, the ground can be covered completely by the tephra fallout to the point that it looks like snow. 6 inches, 8 inches of this tephra, of this ash and pumice all covering the ground, and the vegetation underneath that dies. In addition, people who have gardens and this ash gets into the garden itself, we really have to share with those people that they have to wash their food appropriately before ingesting it. Fruit trees, those kinds of things as well, because of this issue of carrying in those chemicals and ingesting those. Volcanic eruptions also pose a transportation hazard. So the air gets so full of this ash and this tephra and this pumice and very fine particles that many combustion engines no longer work. Combustion engines basically pull in air and then ignite it and create the power inside the engine, and so they have what's called a carburetor that pulls air in from the outside. Even jet engines pull air from the outside, combust it, and then push it out in an exhaust system. But if you have a lot of debris, a lot of ash and pumice and other things that are associated with these volcanic eruptions, this can clog up that carburetor and actually stop whatever's going. So transportation hazards can occur as a result of this. You can have stopped trains, stopped traffic, cars can't run, and most importantly when we're talking about this, planes that have to fly through this stuff, we want to avoid that completely. So you may have heard a few years ago where Iceland volcanoes erupted and disrupted a lot of the air transportation through the areas in Europe and UK all the way down to Spain. That was because these planes cannot fly through that debris. It's too dangerous, and therefore they have to stop the transportation routes. And so you can understand that that would be a particular hazard. Also complicates getting help into these areas that are being affected. There are also issues related to public utilities with these particular eruptions. Power, water, sewer, all lost as well when these volcanic eruptions occur. There may be disruption of the power plant that normally generates the electricity, or the water treatment system may become clogged or and unusable. And of course, we know that endemic diseases, those cardiovascular disease and diabetes and chronic diseases like that, those can worsen, of course, because people are going through the stress and other issues related to volcanic eruptions, just like any other natural disaster. Now, very well localized with a volcanic eruption, in many cases when this tephra actually goes up into the atmosphere, we can see remarkable areas of lightning strikes where the static electricity associated with these particles moving in the air with such energy actually create lightning, and charged particles, oppositely charged particles, then transfer these lightning bolts, and you see this remarkable lightning. And most of the time we don't actually appreciate it during these daytime eruptions, but at night is when you can really see it most remarkable. And certainly take a look at some of the photographs of Santiago in Chile with this current eruption. You can see that happening in a remarkable degree of lightning in that particular event. We also have some of the public health consequences associated with volcanic eruptions in addition to these injuries and illnesses, and I want to look at those one by one as well. We've done that for other types of disasters. We want to do one for each one of the type of natural disasters in this series. And you can see by this particular table, and this figure is showing that toxic exposures are one of the key elements here that we're worried about, and so that's shown in red. Regarding the number of deaths and the number of injuries, we actually can say that in comparison to other natural disasters, it's relatively few to moderate. Remember, we looked at that last 112-year period, not a lot in comparison to some of the large numbers that we see with these other events. But once again, we also see this public concern for safety. People, when they see that dramatic impact of the volcano, they look up and they see the sky filled with this debris and the large dark clouds billowing from the volcano. People's concern always goes up. So we always have to think about communicating to the public in a way to be able to tell them, number one, how to protect themselves, number two, what the real risk is as best as we can understand it, and three, what kinds of things to plan and prepare for. And of course, the best communication comes ahead of time as well. So we want to prepare people in those areas that could potentially be affected. And now the measures that lessen the health impact of disasters, once again, go along three lines: reducing exposures, reducing vulnerability, and improving the capacity. So we are taking the same approach for each one of these natural disasters, and we just do it a little different and for each one of the types. So particularly when we're reducing exposures, what we want to do is evacuate populations that are at high risk. So we need to look at those areas. What populations are potentially impacted from the pyroclastic flow that comes rolling down these things? So those are the populations that are relatively close. But then in the periphery, we also have to be concerned about lahars that can reach quite a much larger distance, or even further distances away where the populations may be exposed to the bad air and the bad water and so on that can be associated with these volcanic disasters. I also want to encourage you to identify these evacuation plans and exercises. And the best thing about a plan is actually that you involve the people who are at risk in the planning process. And why is that? You do that because there's several different good reasons. Number one, it's their lives. You want them as stakeholders in the process. You want them to be able to make the decisions of how they'll do things, why they'll do things, and so on. You also want them to learn in the process of planning. You learn a lot about how is the best way to be able to approach this, and they know more about the local customs, they know more about the local society than you ever will as an outsider. So involving them in the evacuation planning and then practicing these plans and evaluating them through exercises, very key element. So we want to evacuate people, but it's not as easy as it sounds. Just to tell everybody, okay, now go. Question comes, go where? Go why? Go how? And so on. There are also other vulnerable populations that just can't get away. For whatever reason, whether they don't hear the warning, or they're unable to understand it, or maybe they actually can hear it and understand it, but just can't go somewhere because of either their own personal mobility or their ability to be transported. So that's another issue, but reducing exposures, very key. We can also reduce exposures through the community as well, so maintaining these systems, as I mentioned, for mapping the hazard. Where can the volcano actually occur? Where do its hazards go? All can be put on a map. We can also monitor and forecast and predict to some extent of when volcanoes are actually at more risk for exploding or at risk for erupting, and also providing some early warning. So even though we don't know the exact moment, we can still tell populations, look, there's a good chance that this thing is going to be able to turn into a big bad event. We need to get you out of here right now while we still have the time. We can also promote sustainable development in communities. So why build a community at the bottom of a volcano and allow that community to grow and more investments to occur, and then you know that sometime in the future that community is going to be wiped out? We have to think more carefully and plan more effectively at this idea of sustainable development. So what is sustainable development? It means that I build something, whatever I developed, whatever new thing that I build, I have to think about what are the long-term risks. So many of us, of course, we build our homes or we buy homes and so on. We're mostly worried about whether that home is going to be there long enough to take care of us. But we have to start thinking about building communities to where it outlives us. It outlives our children and our children's children, so that we're not transferring that risk of something that we build to future generations to be destroyed. Thinking in terms of sustainable development is a long-term human goal in a lot of ways. It's economically more viable, it's more humane, but it also just really helps communities to be safer overall, choosing where we build. In addition, we support policies for land use regulation in high-risk areas. So we support policies that minimize the amount of impact, not putting critical infrastructure in these areas and not supporting the development of high-risk populations in high-risk areas. We also talked about reducing the vulnerability for these volcanic disasters. And once again, we can reduce the vulnerability of nearly every disaster by doing several key things. And I like to call these my no-regret options. There's no regret for improving health status. Any day, if you can improve someone else's health of a population or a neighborhood, you're getting that benefit that day. But also, healthy people can be evacuated easier. Healthy people understand the disaster that's happening around them, and they can actually be more productive. They can help other people. And also, so therefore, this idea of health status really makes a big difference. Improving people's personal mobility, improving their social network, improving their public knowledge and preparedness, and their communication within the community, it just makes for a better place to live. But it also reduces our disaster risks. So think in terms of that when we're talking about community mobilization, community health promotion, and so on, key elements to making us all safer from disasters. And the third aspect that I mentioned besides exposure and vulnerability is building capacity, right? The capacity to be resilient. As we recall, the capacity is actually the resources. It's the resources that we call upon in order to respond to the disaster and recover for the disaster. So we build these resources in case of the emergency, that we use them then, right? And so, once again, improving access to education, improving people's socioeconomic status, improving health, those are all my no regrets. But also, as well, selecting key structural and non-structural mitigations. So not building hospitals where there may be high risk for inundation or being covered by these volcanic eruptions. We also want to practice in community level large-scale population evacuation measures and teaching people the do's and don'ts about evacuation itself. Now, one of the tragedies we saw in Montserrat in the Caribbean when this volcanic eruption occurred there is people were trapped on their roofs. They survived the initial pyroclastic flow, remember, rolling down the mountain, and they lived through that, luckily so. And they climbed up on top of their roofs and they waited to be rescued. And they waited, and they waited. And actually people got concerned that they wouldn't be rescued and so on. And some people actually got down off the roofs and walked through that hot ash. Well, what they ended up getting were circumferential, or burns that went around their legs themselves. Now, anytime you have a burn that goes all the way around a limb, all the way around your leg, all the way around your arm, it burns the skin in such a way as the skin actually tightens around that limb. Now, you know that if I were to take my hand right now and squeeze my arm tight enough, I could actually cut off the blood supply to my hand. My hand would start be damaged because of that if I did that long enough. That's what occurs in these burns. So the circumferential burn occurs, and then now I may have the burn here, but I lose the hand because now there's no blood supply going to the hand. So the other thing we have to think about too is teaching populations what to do and what not to do, right? The first thing we want is just to evacuate them as soon as possible. Even before, when the eruption looks like it could occur, we want folks out of there as soon as possible. But you know, a good friend of mine yesterday was asking me a question about how do we convince people? Because some people, no matter what, they want to stay. They want to stay in these particular events, and they want to, be strong or protect their property and so on, and they're not thinking in terms of the real ramifications of losing their lives. And how do you convince people? And really all you can do, and what I say with this, is you really have to just be truthful to people. Get that across to them that not only are they putting their own lives in danger, but they're putting other people's lives in danger too. Of course, their families, they'll be very hesitant to do that, of course. But people that are by themselves and say, look, I'm just going to try to weather this out. People they're putting into danger are the responders that may be called upon at the last minute to try to come save them, or they may be injured and unable to help themselves, and responders feeling that need to be able to go out and save someone's life like that will actually go in and put themselves in danger as well. So people that don't evacuate, people that stay behind, you actually put more people in danger as a result of that. We have to get that message across to people to be able to allow them to understand public early warning is for you and for the safety of everyone around you. We're all one big community. We have to recognize we all work together. And so that's the issue with this public early warning and this evacuation. We really got to teach people what to do and what not to do. We also want to develop this resilient critical infrastructure. So we want things that will actually survive these volcanic eruptions. So no hospital at the bottom of the volcano in these high-risk areas, or no power generation power plants or water treatment areas in these high-risk areas. So critical infrastructure, putting that in safe places, building it in places that will be resilient, are actually the best approach to this. And then finally, I just can't stress enough, social cohesion, inclusiveness, bringing everybody together in the planning process, bringing neighborhoods and different ethnicities and different languages and so on, bringing people together ahead of time. People have warm, big hearts. That's all over the world where I go. People are wanting to do something for other people. Taking advantage of that and building that network, building that fabric of the community itself is so important. Being inclusive instead of exclusive, and bringing those folks together at a time when we can all help each other in advance of that disaster, it really does save lives over and over and over. And I can't tell you how important it is to work together. And that's just human nature to do so. So let's not ignore that opportunity to really be building upon social cohesion and inclusiveness.